Hello. Hi,
Hi there.
how are you? Let me meet all of you so I don't get that weird echo. All right, so let's go ahead and get started. First of all, hope you guys had a nice long weekend and were able to, I don't know, stay home, right? So that's all we're doing. All right, I'm gonna go ahead and share my screen. All right, so I'll have the chat open in case you have any questions, or if you have questions, feel free to just speak up and ask your question. Unmute yourself since I muted all of you. Okay, so what I wanted to work today is on your review for your Math 136 portion. And I want to only focus on this. I want you to kind of have to just like have like little, I don't know what they call it, they put them on like the animals, so they just only focus on this, on the horses. I want you only to focus on this because this is part of a final grade, and this is the only thing I'm going to use to determine what your grade should be. There's only two options. There's a pass or no pass. So there's pass or no pass. And I hope all of you get a pass. And what that 136 was just to fill in that algebra that would help you in the 36 course, the parent course. So a lot of it was the factoring, a lot of going back to talk about rationalizing denominators, complex fractions, that stuff that I don't usually take too much time in a trig course. I'll just do a quick, like one question as a warm-up, and that was your quick reminder of how it works, and that's all I do for a regular course. But here, because it's part of our content, I do spend a lot more time on it, more than I would a regular trig course. So your exam will be posted on Thursday, and it'll close on Sunday. That's when your exam will be open. And today I just want to focus on the review portion. All right, so let's go ahead and get started. If there are any questions, please voice your questions. All right, so let's begin with question one. Factor each polynomial. So you're gonna have a question just like this one. It's gonna be maybe question one, depending if it shuffles them or not. So for this question, you're being asked to factor. A factor means I want to think of two, in this case, expressions to when I multiply them will result in what we have, right? Our problem, which is 3x squared minus 11x plus 10. To factor a trinomial, it's heavily dependent on your leading coefficient. There's two main ways to go about it, and it all depends whether there's a 1 or anything else other than a 1. Because there's a 3, we have to go about multiplying your A and your C. 3 times 10 is 30. And then working with your middle term B, which is negative 11. Now you're forced to think, what two numbers can I multiply to get 30? But when I add them, I get 11. All right, so you think, all right, I can get 30 from 3 times 10. That doesn't seem like it'll work. 15 and 2, no. 6 and 5, yeah, that sounds like it could work. Because 6 and 5 make 11. All right, but I want a negative 11. Well, if I make them both negative, it'll make a positive 30, but when I add them, it'll give me that negative 11. So yeah, it requires some thought. Now we're going to replace that middle term with that negative 6 and that negative 5. But make sure to include that x, so that we have 3x squared minus 6x minus 5x plus 10. Now we group our first two and our last two. If we focus on our first two, what is the greatest factor you can factor from both of them? Or you can think of it as, what's the biggest number that and variable that divides into both terms? That would be a 3x, right? So we divide both by a 3x so that we're left with x minus 2. All right, now we're going to do the same thing with our last two. And behind our mind, we should be able to think like, hey, I want to get that same thing in parentheses. So what should I do to get that same thing in parentheses? Again, your greatest common number that divides into both of them would be -5. And then we're left with x minus 2. That worked out. So this divides to be x minus 2 and 3x minus 5. So this was factoring a trinomial with a not being 1, your leading coefficient not being 1. Are there any questions? Nothing in the chat? Nothing in the chat. All right. Now, for number 1, your instructions are to factor the polynomial. Let's go on to B. For B, you're being asked to factor y squared minus 36. This looks totally different than our last problem. So how do we know how to approach it? A big key is that we have two terms. Have that y squared and that 36. And another key point is that it's a minus. When there's two terms in a minus, it's probably going to be difference of squares. How do we know if it's a difference of squares? It's if your terms are perfect squares. So do you see this 36?
Yeah.
Isn't 36 a number we can get from squaring a number?
6.
6, right? We can get that from 6 squared.
Mm-hmm.
And we see this y. I can get that y squared from squaring just a y.
Mm-hmm.
So this is how they set it up in most textbooks and maybe from your past algebra course. We have that y and that 6. So we write it as y plus 6 and y minus 6. And that's the answer. We factored it. So this is number 1 you were asked to factor. They look different, but nonetheless, we still came up with two things that when I multiply them, I get where I started from. That's factoring. It's undoing that multiplication. Any question on number 1?
No, that one's pretty straightforward. I think I remember from my previous classes.
Cool.
I do actually have one quick question. So
Yes.
when I did A,
Mhm.
I switched up the order that I put instead of having x. Okay, so the way I essentially grouped it backwards. You grouped it as 3x squared minus 6x minus 5x plus 10. I did it the other way around. I did 3x squared minus 5x minus 6x plus 10. And so it looks a little different on mine. It still comes out to be the same, but I remember seeing something on Khan Academy saying that the order that you write them in does matter, yet somehow I ended up with the same answer as you did. What's the deal with that? Does it matter?
The answer is no, but yes. No, but yes, because it typically doesn't matter, but there are some very special cases where it doesn't factor unless you switch them around. And the reason that might be is if I have two variables. So what if this was x, y, z, y, z? I would want to group my z's together, right? And I would want to group my y's together. So when you have two variables, there are situations where you do have to rework the problem and move the terms around. But for typical, I believe it's the variables that may cause the problem, but typically there isn't an issue.
Gotcha.
Yeah. So if you plug them in and you get some answer at the end, you're fine. The only time you would have to make sure your ordering is correct or switch the middle terms around is if you're trying to factor and you're stuck. It doesn't move forward. If it doesn't let you continue, then you try moving those middle terms and switch them around.
Understood. Thank you.
Yeah. Good question. But you got the same answer, right?
Yeah, it factored out to be the same.
Great. All right, number 2. Multiply. Simplify the result by combining like terms. All right, so we have to multiply. And multiplication, you have to be very careful. So I'll try to be careful because I make mistakes all the time. So x times x squared gives me x cubed. X times 2x gives me, it's positive, so 2x squared. X times 4, they're both positive, so plus 4x. All right, now we're going to throw in a negative. Negative 2 times positive x squared, we get negative 2x squared. Negative 2 times positive 2x, we get negative 4x. And negative 2 times 2 times positive 4, we get negative 8. So far, so good? Yeah? All right, so now we're going to try to combine like terms. So those are terms that have the same variable and exponent. If so, then we can add and subtract the coefficients. So I only have 1 x cubed, so x cubed. X squares, I have 2. So 2x squared minus 2x squared, that's gone. They add to make 0. And now we have 4x minus 4x. This also adds to make 0. And we're just left with that minus 8. And that's our answer. We multiplied and that was our answer. It so happened that some numbers add up to make 0. But you can, your problem's just asking you to multiply and simplify. And that's what we did. Now, if you look more closely, this is a special case of factoring. This is a difference of cubes. We didn't focus on that because it's not really something that we apply in this course. But this is why it so happened to only add up to be only 2 numbers, x cubed minus 8. All right. B. Again, we're being asked to multiply, and we have 2y minus 3. So we see that square. So we think, okay, great. We just square each number. No, we have to multiply. We have to multiply our expression. So we have to take 2y minus 3 and multiply it by 2y minus 3. We're multiplying it by itself twice. Therefore, we're using the exponent, right? We're just expanding our exponent. Now you can go ahead and multiply. You can remember the special case for multiplying by a square, or you can just multiply. So 2y times 2y gives me 4y squared. 2y times negative 3 gives me minus 6y. Negative 3 times 2y, we get negative 6y. And negative 3 times negative 3 gives me positive 9. So this simplifies to be 4y squared. We have like terms right here. So it's minus 12y plus 9. All right, those are our first 2 terms. First 2 problems. All right, your best friend, rationalizing denominators. And I say best friend because you do it all the time. So by force, it did become your best friend. All right, number 3, you're asked to rationalize the denominator and simplify the result. I will try to trick you. I will try to trick you, particularly with simplify. All right, so we want to rationalize the denominator. What this means is we don't want a radical in denominator, right? That's what it means to rationalize. And it says the denominator because you can both rationalize the numerator as well. But for math, we don't typically like to keep radicals in the denominator. All right, to undo that square root of 6, I'm going to multiply it by 1, but by a special one. So I'm going to multiply it by square root of 6 over square root of 6. Square root of 6 times square root of 6, that gives me square root of 36, which is 6, right? In the numerator, I have square root of 6. So I'm left with square root of 6, and the square root of 36 is 6. And that's our answer. There's no more simplifying necessary. All right, let's move on to B. B is going to be different. All right, so I want to rationalize. So I want to multiply the top and bottom by square root of 5. This in return will give us square root of 25 in the bottom, and square root of 25 is just 5. But in the numerator, I'm left with 20 times square root of 5. What we notice here, I have to be careful of, and why we're being asked to simplify, is that fraction of 20 over 5 can be simplified. 20 over 5, or 20 divided by 5, gives us 4. So we're left with 4 square root of 5. Or to be a bit more careful, 5 goes into 5 once, and 5 goes into 20 4 times. So we're left with 4 over 1, which is 4. Any questions about 3?
No, ma'am.
No, ma'am. You call me ma'am because you can see my grades. They're there.
Oh, sorry. It's just a habit.
All right.
Trust me, I'm older too.
Okay. 4. Use a technique of algebra to solve the equation. Should work. All right. So we worked with these problems when we worked in chapter 6 and we're trying to solve equations. Okay. For number 4a, we have a quadratic. And we have seen how if I have 2 products, I can just set them equal to 0. But that's a key part. It needs to be a 0. If it's anything other than a 0, we have to change it. So for this type of problem, I first have to multiply it out. And then set it equal to 0. And to that, I have to subtract 8 to both sides, right? And then I will try to factor to set each factor equal to 0. All right, let's go ahead and do that. So what makes this one different is I have to first multiply it out. All right, so let's multiply. X times x gives me x squared. X times positive 1, positive 1x. Negative 6 times x minus 6x. And negative 6 times 1 minus 6 equal to 8. All right, I want to combine like terms. I see there's 2 terms with a variable of x. So this gives me x squared minus 5x minus 6 is equal to 8. All right, I first had to multiply it out so that I can work back that 8. The reason I need to work back in that 8 is because I need to set equal to 0. All right, so let's go ahead and subtract 8 to both sides. That's this side right here, that second step. So I have x squared minus 5x, and negative 6 minus 8, that gives us 14 minus 14 is equal to 0. All right, now we can try to factor. All of the problems that you'll see in your exam will be factorable, or you use square root property. I won't try to sneak in quadratic formula because there's other things that I'm focusing a bit more on. All right, so they should factor negative 14 and negative 5. All right, we get negative 14 by 7 times 2 and negative 5. So I'm going to make one of them negative. Negative 7 plus 2 gives me negative 5. Negative 7 times 2, negative 14. Okay, great. So let's go ahead and take these numbers and write it as x minus 7 and x plus 2 equals 0. Now notice I didn't take that a and multiply it by my c. I mean, we could, but because it's a 1, I can just look at my c, and whatever two numbers I have, those will produce my factors. Because our leading coefficient is 1, and that's the easier case. There's two cases for factoring trinomials if they're factorable. All right, we set each one equal to 0. So we have x minus 7 is equal to 0, and x plus 2 is equal to 0. And we're going to solve for x by setting each one equal to 0 and solving. So we go ahead and add 7 to both sides. We get x is equal to 7. Subtract 2 to both sides. We get x is equal to negative 2. And those are our two answers. X is equal to 7 and x is equal to 2. That's 4A. Any questions about 4A? No?
No.
All right. Thank you. Okay, let's take a look at B. You can go ahead and solve B same as before as 4A, but because we have a single expression or a single term squared, I can use the square root property. And we are pros at square root property because we do it all the time, especially when we're dealing with Pythagorean theorem, right? So we want to get x by itself, and this square is bothering it. That square is a problem. So we can go ahead and take the square root of both sides. The square root and square are mathematical inverses, so it's gone. But the thing about square root property is when I take the square root of both sides, I need to write plus or minus. So don't forget that plus or minus. So we're left with x minus 5
at work or no?
is equal to 5. All right, let's go ahead and get x by itself. Let's go ahead and add 5. Add 5. So I have x is equal to 5 plus or minus 5. So we have to write it twice. We have x is equal to 5 plus 5, and x is equal to 5 minus 5. And this will produce two different answers. So you get x is equal to 10, and x is equal to 0. And those are our two answers, 10 and 0. And this is by the use of our square root property. So these are the two problems for number 4. All right, let's continue with 5. So we talked about this way back, but I'm going to exclude this problem from our review, mainly because inputting these images is going to be really challenging and a lot of work, so I'll just skip it all together. So it won't be there, but I still want you to know how to go about these problems. So number 5 reads, determine whether the graph of a function is 1-to-1, if not, state why. All right, so the thing about 1-to-1 and onto is if it's a function, it passes the vertical line test. So it first has to be a function before it can be a 1-to-1 function. Now for it to be 1-to-1, it has to pass the horizontal line test. So it has to pass 2 tests. And if ever crosses the line twice, then we say it's not that. So 1-to-1 function is a special type of function. All right, so let's take a look at this first one, x squared, f of x equal to x squared. So this one cannot be a function because straight off the bat, we see that it fails the horizontal line test, right? It crosses the line twice from one line. So we can say, is it 1 to 1? We say no. And we can say it fails horizontal line test. Let's take a look at G. Let's draw a horizontal line test. And we see that one fails as well. We see that it crosses the line more than once. So is G 1 to 1? We say no. And again, it fails horizontal line test. Let's take a look at H. We draw a horizontal line. And no matter how many horizontal lines they cross, it only crosses our graph once. So for H, we can say, is H 1 to 1? We say yes. And you can say it passes the horizontal line test. Now, another option to this answer, instead of using the horizontal line test, you can say yes, because for every one x, there's only one y. Or because there is only one x for every one y. So I won't ask a question about this, but this is one of the concepts for your Math 136. This is part of your SLOs, our description of the course. All right, number 6. I'm going to skip number 6 too. I'm going to scratch the one off because I don't remember focusing this at all. I remember we did one-to-one functions in the horizontal line test, but I don't particularly remember working on domains. So I'm going to scratch off number 6. But I still want to work it out with you so you remember this for your pre-cal, because you're going to see this in pre-cal. So identify the domain of your function. The domain is, what I always think of when I see domain is, what can x be? Is there a restriction? Is there something that's going to cause it to be undefined, or I, because we don't want to deal with i's, or I? Those are the two main issues that will give us a problem in our domain. So let's find these cases. So let's take a look at A. If we look at A, there's one problem where we have this x in the denominator, and we don't want to make a 0 in the denominator because that would make it undefined, right? So this is our problem. We need to find out when it's equal to 0 because that's the only one point that can't work out. All right, so let's go ahead and solve it for 0. So we have 3x minus 4 and find out when it's equal to 0. All right, so we solve for x. So we add 4 to both sides. So we have 3x is equal to 4 divided by 3 divided by 3. We have x is equal to 4 over 3. So our answer is that x can never equal 4 over 3, because only in that situation will we get a 0 in the denominator. And in that situation, it would make our function undefined. So for our domain, we can say all real numbers except x is equal to 4 over 3. So you can write it in English. You can also use interval notation. So this is one way of writing it. You can also write it as all numbers. And you take a break at 4 over 3, right? That's your interval notation. And you can also write it at set builder, but I won't write it at set builder because it's not the popular one. Interval notation is the popular way to write it. All right, so domain is what can x be? Let's take a look at B. Question B. So the problem here is that I have a square root And the number inside the square root, I need to make sure that number inside is positive, right? So in other words, I need to make sure that whatever expression is within the radical has to be greater or equal to 0, whatever this may be. So if you ever have anything with a radical, with an even index radical, meaning square roots, fourth roots, sixth roots, we can't take the square root or an even index radical of a negative number. So I can never have the inside of my radical be negative. So that's when I find out when it's greater than 0, but 0 is okay. So I can make it equal to 0, hence that greater or equal to 0. So let's go ahead and do that. So we take that 2x plus 1, and we find out when it's greater or equal to 0. So we subtract 1, we have 2x is greater or equal to negative 1, divided by 2 because we want to get x by itself. We get x is greater or equal to negative 1/2. So this is saying x has to be greater or equal to negative 1/2. If it helps you take a look at your numbers, you can always draw a number line. We're saying that it can be greater than 1/2, 1/2's included. I don't know, sometimes drawing a number line makes it click in my brain so I can see all the numbers represented by a number line and see what works and what doesn't work. All right, so our answer, our domain is when x is greater or equal to 0. Oh, sorry, greater or equal to negative 1/2, not 0. If you want to write as internal notation, then it'd be negative 1/2 to infinity. Infinity is always use a parentheses, and because we're including that 1/2, we will use a bracket. All right, so for this, it won't be on your exam, but I did want to go over it because I don't remember if we did. And this is a concept that you will see again in your pre-cal course, domains. Question?
I'll probably have to look over these a little bit more, but not right now.
Okay.
Yeah, I do have a question. At what point would this have been taught to us?
This would have been taught maybe around chapter 5 when I'm working over functions. When I'm getting you ready for chapter 6 when we work with equations. So I talk about functions and what they mean, and then we go into factoring. So sometime between chapter 4 and chapter 5.
There, the word domain was dropped somewhere in the textbook, but as far as like, yeah, I've never seen anything like this before.
Oh man. Well, domains we see when we are graphing because there are situations that affect your domain, particularly when you're graphing tangent of x, right? When you're being asked to graph tangent of x, well, tangent of x is sine of x over cosine of x. And this is where I would focus more or spend that 1 hour class that is meant for this to say, hey, okay, let's talk about functions. And I would do some problems that have asymptotes and then be like, okay, well, what's your domain? Well, if cosine is ever 0, then we're left with an undefined situation, right? Because cosine being 0 in the denominator would make a 0 in the denominator, hence undefined. And this is what creates your asymptotes for your tangent functions. Those invisible lines that we don't cross, right? When you're graphing tangent, you graph your asymptotes. And then from there, you draw your branches.
Sure, okay.
Right.
Professor, I have a quick question. Are we turning in this review like we did with the last one? Is there going to be an upload for it, or are we just reviewing it for the final on Thursday?
We're just reviewing it for the final.
Okay, I just want to make sure. I know the final itself is in the classes pass or fail, I think you said.
Yeah.
Okay, all right. Sounds good. Some stuff to study.
Okay. But I mean, if it's helpful, 6 and 5 will not be on your exam. I just want to make sure you at least saw it once, so when you see it again, it's not completely new.
Okay. Thank you,
Right.
Professor.
Thank you. All right, number 7. Given that f of x is equal to square root of 3x plus 15, find the following. So I remember we briefly talked about function notation. Very briefly, I think in the beginning of our quarantine time. So function notation is the same thing as saying y, right? So it'll be the same thing saying y is equal to the square root of 3x plus 15. But what's really cool about function notation is it saves a lot of that English. We don't have to talk as much in our instructions. So we can say something like f of 22. It'd be the same thing as writing in English saying let x equal 22, then solve. That's what that's saying. Something along those lines. It's saying plug into 22. That's function notation. So let's go ahead and do that. So we're going to plug in 22 into our x. So we have square root of 3x plus 15. And it's saying to plug in a 22 for your x. So let's go ahead and do that. So we have square root of 3 times 22 plus 15. All right. 3 times 22 is 66 plus 15. That gives me 76 plus 5, 81. Square root of 81. The square root of 81 is 9. And that's our answer. We can write it as f of 22 is equal to 9. All right, 7b. F of 1 over 3. So this is saying same thing. We're going to take our function f and we're going to plug in a 1/3. So I have 3 of x, 3 times x plus 15. And we're going to plug in a 1/3 for x. So that we have the square root of 3 times 1/3 plus 15. All right, cool. 3 times 1/3, that gives us 1. And we're left with the square root of 15. And we can't simplify that any further. So that's our answer. All right, it makes a 1. My mistake. 3 times 1/3 is 1. So we're left with 1 plus 15. 1 plus 15 gives us 16, which gives us 4. Square root of 16 is 4. So we're left with f of 1/3 is equal to 4. All right, that's number 7. Number 8. Given the binomial 2x minus 5, two-part question. A, what's a conjugate? Well, we recall that a conjugate is same numbers, different sign in the middle. In this problem, our sign's a minus. So for our conjugate, it'll be a plus. So we have 2x plus 5. And that's it. That's our conjugate. That's 8a. B, what is the product of 2x minus 5 and its conjugate? All right, so its conjugate is 2x plus 5, right? So we want to multiply both of them. That's what means their product. So we have 2x plus 5 times 2x minus 5. All right, you can multiply them out, or you can recall that it's a difference of squares. And you take your a and your b and you square each one. 2x squared minus 5 squared. And this gives us 4x minus 25, 4x squared. Now, if for some reason you don't recall that, you can go ahead and just multiply it out. 2x times 2x, 2x times -5, 5 times 2x, And 5 times -5, and you'll get the same answer. Again, that's the beauty of math. As long as you follow the rules, you'll be fine.
I had a quick question on 7B, if you don't
Yes.
mind. Why is it for sure +4 and not either positive or -4?
We only have to write square root plus or minuses when we take the square root property, such as y squared is equal to 16. So because we're taking the square root of both sides, that's why we write plus or minus. Here, we did not have to apply the square root on both sides. We simply were given a square root.
Okay. So, okay, no, because you're right. So you're not saying that the square root of 16 itself is negative. It's just.
Okay, so I'm giving you two different problems. If I give you y squared is equal to 16, it's very different than if I give you y is equal to square root of 16. So if this is straight off your problem, how you first see your problem, it's different because on the first one, the problem is I need to get y by itself. What can I do to get y by itself? Okay, well, I see the square, so I have to take the square root. So I can take the square and the square root are mathematical opposites, so now they're gone. Now I have y by itself. This process is called the square root property, and that's when I do plus or minus. Now, if I were given in pink on the right is just y equals square root of 16, I never had to apply the square root of both sides. When you force the square root of both sides, well, not force, but when you apply the square root of both sides, that action is called the square root property. And by doing so, I need to be careful. I need to be careful of that y being a 4 or a -4. If I'm just given that y is equal to square root of 16, okay, then I can just take the square root of 16 and we get 4. So what's different here is that in our function f, we were given the square root. We never had to take the square root of both sides.
Okay. In reality, though, the square root of 16 is both, right? It is both 4 and -4. Is it not?
Yes and no. When you first define square roots, by definition of square roots, you are working with positive integers only. So I always wonder, like, when I open my internet, what it's going to be there. I'm like, oh my gosh. Okay. So definition of radical. We should put math. Trying to find like a very just like short. This is definition. Okay, so here we see radicals, and it's used to indicate the root is called a radical and is therefore read as x radical of radical n, or the nth root of x, and the radical symbol, the horizontal. But they don't talk about the variable. Yeah. Well, if you get a textbook and they talk about when they very first see radicals, I'll find one on one of the textbooks that I have. they define it that it's the positive outcome of it. And the reason why is because you're not specifically saying what two numbers are being multiplied. So you're limiting it to only being the positive ones. With the square root property, we're not sure which one we're taking, the positive or the negative. So that's why we have to consider both.
Okay. I mean, sometimes it makes perfect sense. Like if you're measuring a distance, you can't have a negative distance or whatever. But I just don't. Other
But then
than
you
that
still have to be
situation.
careful because it also depends on what quadrant you're in and if you're taking the square root to find your x coordinate or your y coordinate. So that's something that is very important for this course because it's not always going to be straight off plus or minus or straight off plus. You have to be very careful for every single problem what you're given. All right. So let's continue with number 9. Simplify this complex fraction. All right, so let's first simplify the numerator and then simplify the denominator before we attack this division problem. So for the numerator, I'm being asked to add 5 over 12 plus 1/3. Okay, so we need to multiply by a 4 over 4 so I can get that same denominator of 12, right? Okay, so we're left with 5 over 12 plus 4 over 12. That gives us 9 over 12. All right, in our denominator, we want to get a same denominator. We have a 3 and a 4 for our denominators. So let's go ahead and multiply each one by a 3 and then a 4. 4 over 4 and 3 over 3. This will get us to have a denominator of 12. So that we have 2 times 4 is 8 over 12 minus 1 times 3 is 3, 4 times 3 is 12. And then we can subtract 8 minus 3 is 5. So we have 5 over 12. All right, now that we simplified each one separately, you can go ahead and rewrite it so that we have 9 over 12 divided by 5 over 12. And that's something we know how to do. We've done it so many times. It's easier to see if you rewrite it. Remember, that's just a division sign. So this can be rewritten to be 9 over 12 divided by 5 over 12. Remember to change the multiplication and flip the second. So I have 9 over 12 times 12 over 5. And then we see that our 12s can divide to make 1. They're gone. Our final answer is 9 over 5. And that's complex fraction. Group your numerators and group your numerator and simplify, group your denominator and simplify, and then look at the fraction as a whole. All right, number 10. Given the right triangle ABC given the side of measures, find the length of the third side. Simplify the results. Note, C is the hypotenuse. So if we have a triangle, it's telling you we have a right triangle, so 90 degrees. And C is that right. I should be more precise. The hypotenuse, also the right angle. Okay, so we have A, B, and C. So we have some measurements given. You can always draw a triangle for each one if that's helpful. And it's telling us that A is 2 square root of 5 and B is 4. We're left to find C, right? C is our unknown. So because we have a right triangle, we can just go ahead and continue with the Pythagorean theorem. A squared plus B squared is equal to C squared. All right, so A is 2 square root of 5 squared plus b squared. B is 4 squared. And that gives us c squared. All right, now we have to go ahead and multiply, square each term. Now the square applies to each one. There's no plus or minus, so it's the whole term is together. So 4 squared gives us 4 squared. 2 squared gives us 4. Square root of 5 squared gives us 5. Plus 4 squared is 16 is equal to c squared. 4 times 5 is 20. Plus 16, you get c squared. 20 plus 16 is 36. All right, we want to get c by itself, so we take the square root of both sides. Plus or minus, well, we only want plus because it's the distance of a triangle. So we have 6 is equal to c. And that's our answer. All right, let's take a look at B. Same deal, we have a right triangle. And it told me that C was our hypotenuse and our right angle. And here we're saying that A is 5 and C is 7. All right, our Pythagorean theorem is A squared plus B squared equals C squared. Let's fill in those pieces. A squared, well, A squared is 5. So I have 5 squared plus B squared. We don't know what B is. That's our unknown. So we leave it as B squared is equal to C squared, and C squared is 7. 7 squared. All right, let's go ahead and work it out. 5 squared is 25 plus B squared is equal to 49. I want to get B by itself, so let's move 25. Minus 25 minus 25. 9 minus 5 is 4. 4 minus 2 is 2. So left with B squared is equal to 24. All right, square root property. We want B by itself. To get that square out of the way, let's take the square root of both sides. All right, so we're left with B is equal to square root of 24. And we want to simplify. If this were your test, 24 would be an option. Square root of 24 would be an option. Doesn't mean it's the correct option because I can simplify. I can get 24 from 6 times 4. And why am I choosing 6 times 4? Because 4 is a perfect square. I can take the square root of 4. Right? Square root of 6 times square root of 4. The square root of 4 is 2. And my answer is 2 square root of 6. This is the correct answer. Hence, simplify your results. Now I know this part of simplifying is something that gave us hiccups in the beginning of the semester. Are there any questions about this?
No, Miss Angelica.
All right, thank you. Thank you for not calling me ma'am. All right.
Try to change it up a little bit, keep it fresh.
Okay, last one. I should have changed these directions, so now we're not rationalizing. We're simplifying the result. We're adding and subtracting. I can trust you can do this. This is something that, this is the last handout I passed out to you guys when I asked to add and subtract fractions with unlike denominators. And this was to get us ready to work with radians, right? So I threw in some pi just to make it a bit tricky. I guess I'd say a bit more tricky. All right, so our idea here is we want to get a common denominator so we can add and subtract these fractions. All right, so let's multiply. Well, they're not the same denominator, and I see that if I multiply that 4 by a 3 and that 3 by a 4, they'll give me a 12, and thus a like denominator. So multiply by 3 over 3, multiply by a 4 over 4. And so we get 3 times pi, we get 3 pi. 3 times 4, 12. 2 pi times 4, we get 8 pi. And 3 times 4, we get 12. And we add them. Okay, now we achieve the goal of having that same denominator, which stays. And 3 plus 8 gives us 11. And our answer is 11 pi over 12. Before we box it, we make sure that's fully reduced, and it is. And that's our answer. Last one. We want to subtract these two. Same deal, they don't have the same denominator, but this one requires less effort because I see that if I multiply that 3 by a 2, that would give me a 6, which is my denominator of my first term. All right, so we're left with pi over 6 minus, we multiply 5 pi times 2, 10 pi, and 3 times 2, 6. All right, we have that common denominator. In this case, it's 6. Pi minus 10 pi gives us negative 9 pi. Now, before we box it, we see there we can reduce it. 9 and 3 have a common factor of 3. 9 and 6. 9 and 6 have a common factor of 3. 6 divided by 3 gives us 2. 9 divided by 3 gives us 3. So this simplifies to be negative 3 pi over 2. All right, that's the last of your review. So let me talk about your exam. So your exam will be available as of Thursday. You'll have from Thursday to Sunday. I might open it sooner. I'm just typing away, trying to type it out. But it's a lot of typing because I need to type in every version, meaning I don't give you guys all the same tests. So I have to create test banks with several versions of each problem. And I'm making a multiple choice so that it helps you out. So I need to create the multiple choices. So it takes a bit of effort. So hopefully your exam will be open. Well, it'll be open by Thursday. It's going to be open from Thursday to Sunday, closes on Sunday midnight. If I finish it sooner, I'll post it and I'll just post shoot out an announcement letting you know it's available to you in case you want to get a head start. This review is what you'll see on your exam. I'll just change up the numbers a bit so it's not the exact same problem from your review, but this is what you'll see. Instead of seeing A, B for each option, each problem will be a number. So for 11, you won't see 11A and 11B. It'll be like 11 and then 12, right? So it's going to be a bit more numbers, but same type of problems. It'll be multiple choice. And I'll give you 2 tries.
Sweet.
And that's more. You're welcome. And that's more than
That's more than most finals. Let's just say that.
Yeah, because it's just once and you're done, right? So I'm giving you 2 chances. Now, your percent needs to be 70% or higher, right, on your exam. So make sure that the grade you have, it doesn't have to be perfect. It doesn't matter if you get an 80 or 90, you'll still get a pass. So make sure you get 70% or higher.
Did you say how many questions already? Do you know, or are you?
We can count them out. Let's see.
Oh, okay. Yeah, it's just a review. Yeah. Okay.
Yeah. I think I counted them out. Did I? Yeah, it'll be 17 questions.
Oh, okay. Sweet.
But it's these questions minus the 2 that I said I wouldn't include. So the one with the 1 to 1, so 5 and 6. Those 2 won't be there. But each question we did adds up to 17 questions.
Okay.
Yeah. So I guess you can add that down, 17 questions. All multiple choice. Just make sure you get a 70 or above. And it's pass, no pass.
And then how long, Professor? I'm sorry.
I'm thinking maybe an hour 30.
Okay.
Just because I think you can do it in a lot less time than that because some are pretty quick. Some are a bit more work, but most of them are pretty quick. But I know you're home and there's siblings, there's children, there's noise. I know you have a lot more distractions than if you were just sitting on a desk in a classroom.
I just can't wait till the libraries open up. I can't study at home, so I feel you
I
on
can't
that.
do anything at home.
Exactly.
I drink so much coffee
Yeah,
just so that I don't just go to my bed with my cats.
it's just a lot more distractions at home.
I know. I know. I feel the same way. It's really hard for me as well, especially with
I never
allergies.
thought as an adult I'd find myself missing the library and the study rooms.
I never thought school would ever be an option, or being at school would never be an option. As a student, I would drive myself to campus on a weekend when nothing is there. I would drive myself to school on a weekend just so that I could focus because I can't focus at home.
At home.
There's a refrigerator, there's a bed, there's TV.
True.
And
I find if I make myself drive out of the way to the library or at campus, I make
you're
myself
forced
study.
to.
It's like when I drive to the gym. When I find myself driving to the gym, I make myself work out. It's like I drive
Yes.
myself to the library, I force myself to study and commit a lot of time to it.
Yeah. Versus when you're home, you get dressed up to work out and then you just look at the video without motivation. You just sit there and look at it. All right. So that's it for today. I wanted to create I don't want to keep you on Zoom for too long. I know it's tiring and it's in the semester, getting close in the semester. We have 2 more weeks. So this week and 1 more week and then your finals and we're done. I will post videos for the last 2 sections of chapter 7. So those are sections 7.5 and 7.6. I'll post videos and that will be your Thursday lecture.
So is this our last live class, Professor?
No, because I still want to review with you for your final. So we'll meet on Tuesday. We'll start reviewing. I'm hoping to cut the review into 2 large chunks.
Okay.
If you want to get ahead, if you have some time on the weekend, you can go ahead and start looking at your review.
Okay.
So there'll be no live lecture on Thursday. I'll post the videos. But I'll see you on Tuesday.
Alrighty. Thank you, Professor.
Yeah. If you want to get a head start on your final review, you can go to your website, your best friend website, and under pretest and answers, there is a pretest for your final exam pretest.
Final exam pretest? Okay.
Yeah. Now your final will be a combination of multiple choice and open response, and it's pretty much this. So you have an open response part, and then there's also a multiple choice. The multiple choice is pretty straightforward. Sorry, I didn't mean to cut you off. Are you asking?
Yeah, just really quick. Are we uploading this as well?
No, maybe not for the final because it's already too many things that I'm trying to get done to get grades in. But you can start taking a look at the final review. It's pretty straightforward. It's mostly chapter 3 stuff. It's a lot of knowing how to use your unit circle. So make sure you have your unit circle handy as you work through your final exam pretests.
All right. How soon will we know about the, so just basically like right away, we'll know if we pass or fail the 136 part? Okay.
But I mean, I think I give you 2 chances. So make sure you study, do the review a couple of times. If you have questions, you can email me. If you need to talk to me, we can set up a Zoom time for us to meet. I'm available. I'm here. I just don't, especially since it's getting kind of warmer, I don't want to keep you just in one place while in Zoom lecture.
All right. I appreciate that, Professor. Take care. I'll see you on Tuesday.
Thank you. Thanks for your input. I'll see you all on Tuesday. Your 136 exam will post, and I'll post videos for Thursday's lecture.
Thank you.
Thank you.
Bye.